Hi everyone, so this is chapter 2 revision quiz. So based on your response in the Google form, the questions that we will discuss will be question 13, 16 and 25. Okay, so we have question 13. Question 13 says, when is the average velocity of an object equal to the instantaneous velocity? So it's asking for when is it that the average velocity is equal to the instantaneous velocity. When? Okay. Well, this is one of the thing being mentioned in your notes, I think. But the answer is when the velocity is constant. Okay. I want this graph. This is when the velocity is constant. Why? Okay. If your velocity is constant, your velocity time graph will probably look something like this. Okay, this means constant velocity. Okay, so if a velocity is constant, it's like these little dots. Okay, I have told you in class before that actually a line graph is basically just a series of dots being connected together. Okay, so each particular dot represents the instantaneous velocity at one moment. Okay, so if here it's 5 meter per second, then instantaneous velocity here is 5. The delta is also 5. It's also 5 here. It's also 5. It's also 5. 5, 5, 5, 5, 5. At all time, the instantaneous velocity keeps constant at 5. Okay, so if you take the average velocity, average means by you get the average, right? It will be 5 plus 5 plus 5 plus 5 plus 5 plus a lot of 5 divide by the number of 5 you add. Okay, if you have 10 5, then 5, you add 10 times of 5, which is 50, divide by the number of 5 you add, which is 10 times 50 divided by 5, you get back 5 meter per second. So this will be equal to your instantaneous velocity. Okay, in our syllabus we probably don't explain like this when it comes to average. When it comes to average, we usually take the final minus the initial, right? So let's try doing it using position time graph instead. If it's a position time graph, a constant velocity will produce a displacement graph that looks like this. It will be a linear line. Okay, a linear line. So this is what the displacement time graph looks like. Okay, so if we ask about instantaneous velocity, remember velocity it's gradient. Okay, for displacement time graph, find instantaneous or find any velocity through gradient. Okay, so if you want to find the average velocity will be initial, final. So we take our S2, S1 divide by t2, t1. Then you get the average velocity. But how about v, the instantaneous velocity? We can do it by drawing small triangles here and get the gradient. And draw a little triangle here and get gradient. Just like how you do it. As that this triangle is very small because you want to find the gradient at that particular moment. Okay, so if the ST graph is a linear line, the small triangle should have the same gradient as the big triangle. As the big triangle. So if they have the same gradient, what it means by it should be same. Okay, for average and instantaneous. Okay, this little gradient triangle here, we have the same gradient as the big triangle here. So they will be the same answer. So you should know that the average and the instantaneous velocity are the same. Okay. So question 16. Question 16, it's a bit complicated. Okay. The trajectory of a golf ball projected at speed v at an angle of 45 degrees as shown in the figure above. The range is r. Okay. The range is here. And the maximum height h, which is here, is h. Okay, when the golf ball is again projected with the same speed by an angle of 30 degrees, the range you get is r1 and the height you get is h1. Okay, so before this you do it at 45 degrees. This is your ground. Then your thing probably goes like this. If that's the case, you can measure this to be r, and you can measure this to be your h. Okay, now it's saying that if I change it to 30 degrees, so how will your things look like? Okay, so you're asking for r1 and h1. Okay, that's what the question is asking for. I will probably give you something which is for sure. One thing is maximum range happens when theta is equals to 45 degrees. Okay, the derivation is complicated because it involves finding dr over d theta equals to 0. This is something you learn in SPM on finding minimum and maximum point. But not important. You will not need to derive this. What you need to know is maximum range happens when theta equals to 45 degrees. So if it's 30 degrees, it will be smaller than the maximum range. We know r is maximum, means by r1 must be smaller than r. okay, because r is maximum. If we go at other angles beside 45 degrees, we go at angle 30 degrees here, which is not 45, we know that the range will not be maximum. It will definitely be smaller than maximum. If smaller than maximum, means by the answer allowed is only this and this. So we have to choose between this second option and fourth option here. So we also know that if we launch something at 30 degrees, it means by, if we launch something, with an initial velocity at 45 degrees, you resolve this thing to ux and uy, and you do the same thing for 30 degrees, you resolve this thing you see that if the angle is small, you get the shorter, smaller uy compared to if you have a larger angle, you have a larger uy. Okay, in that case, if you have a smaller initial vertical velocity, if this is small, you can only go up for a certain height. If you have a larger initial vertical velocity, you can go higher. Makes sense, right? Okay, therefore we know that h1 will be smaller than h. Okay, h1 will be smaller than h because you have a smaller initial velocity. Smaller initial vertical velocity means you can only go smaller heights compared to 45 degrees. That's why the answer will be this. Okay, next question, question 25. A soccer ball is kicked with a velocity of 25 meters per second at an angle 45 degrees above the horizontal. What is the vertical component of its acceleration as it travels along the trajectory? Well, this question, it's a relatively direct question. You have a ball, the ball is being kicked with 25 meters per second, 45 degrees. Then you go through a certain trajectory. Okay, so what is the vertical component of its acceleration? Means by what is this vertical component? Vertical component of acceleration is this, right? Well, to know the vertical component of acceleration, we have learned it from projectile motion that ay must be always equals to negative 9.81 meters per second square. That's why the answer will be this. Okay, there's no resolving into components here. Ay will always be negative 9.81. 9.81 is because of gravity. Negative is because it's pointing downwards. Okay, if you are not sure about it, you can try to construct a free body diagram. A free body diagram for this ball will only have weight. There will be no normal, there will be no friction, there will be no external force, there will be no normal force. Okay, there's only weight because the ball is in the air, nothing touching it, nothing exerting force on it except for gravity. So if that's the case, we can do sum of F equals to ma, and since we know the only F we have here is weight, weight will be equals to ma. Okay, then we know mg, ma. Therefore A is equals to G. But we take weight here as positive because we follow the direction of acceleration. Direction of acceleration is A is pointing downwards, right? So we take W as positive. But in chapter 2, in chapter 2, you always assume positive, right? That's why in that case, going down should be negative. That's why in chapter 2, you write your A equals to negative G, or you call it negative 9.81 meter per second square. Okay, this is chapter 4. Chapter 4, because to make our calculation easier, we let the positive follow the direction of acceleration. We let the positive be flexible as long as you follow the direction of acceleration. But for chapter 2, we fix our positive. We don't let our positive be flexible. We fix our positive to be up and right, or negative to be down and left. Therefore, in that case, acceleration is pointing downwards. That's why it's a negative sign. Okay, so you have to be careful what chapter you are dealing with. Then you have to understand the maths in order to understand when should you put positive, when should you put negative. Okay, so basically that's the explanation for chapter 2 revision quiz. Thank you.